Many real-life sets of data have distributions that are approximately symmetric and bell-shaped. The empirical rule applies to these distributions, and this rule allows us to use the standard deviation to approximate how much data can fall within 1, 2, and 3 standard deviations of the mean. This can be really helpful for estimations in marketing and planning and other types of situations. The empirical rule tells us that when we have a symmetric or bell-shaped distribution, the standard deviation will have the following characteristics. Approximately 68% of the data will fall within 1 standard deviation of the mean. In other words, if I add 1 standard deviation to the right of the mean or subtract a standard deviation to the left of the mean, I will capture about 68% of the data. About 95% of the data will lie within 2 standard deviations of the mean, and about 99.7% of the data will be captured within 3 standard deviations of the mean. So let's apply this to one of the problems. Given that the mean value of land and buildings per acre from a sample of farms is $1,500, with a standard deviation of 200, let's estimate the percent of farms whose land and building values per acre are between $1,300 and $1,700. We are to assume the dataset has a bell-shaped distribution. Here is a bell-shaped distribution that we can use. Notice that in the middle, I've drawn a line for the mean. 68% of the data is going to fall within 1 standard deviation of the mean, from here to here. From here to here is 2 standard deviations. That's going to capture 95% of the data. And from here to here is 3 standard deviations of the mean. That's going to capture 99.7% of the data. My job is to determine which percentage of the data will be captured between 1,300 and 1,700. So let me show you how to do that. We're going to use this same graphic, but I've removed some of the pieces, and I'm going to let you fill in the rest while I fill in. In our problem, the mean is given as 1,500. Let's use a different color that's easier to see here. The mean is given as 1,500, and the standard deviation is given as 200. In our bell curve, the mean always falls in the center. So I'm going to fill in the mean right here in the center. Now my standard deviation is 200. That means for every standard deviation, I add 200 or subtract 200 from my mean. So to move out 1 standard deviation from here, I add 200 to my mean. So 1 standard deviation to the right puts me at 1,700 because I added 200 to my mean. That's 1 standard deviation. That looks like a 6. And then to go back a standard deviation, I take a standard deviation away from the mean. So in this direction, I'm at 1,300. So I've already answered my question. The question asked, estimate the percent of farms whose land and building values per acre are between 1,300 and 1,700. Well, according to the empirical rule, the amount of data that lies within 1 standard deviation of the mean is 68%. I could continue on with this problem and find out the amount of data that is captured by 95% of the data, or captured by 2 standard deviations of the mean. 95% of the data will be captured between what 2 values? Well, I can add another standard deviation. So in this case, I would add 2 standard deviations and go out to 1,900 on the right, and I subtract again over here, and I come up to 1,100. So 95% of the data would be captured by 1,100 and 1,900. And if I continue on, 3 standard deviations capturing 99.7% of the data, I would have 2,100 and 900. Again, just adding and subtracting another standard deviation of 200. So here I add another 200 and another 200. And here I subtract another 200 and subtract another 200. And that's how you apply the bell curve or the empirical rule in order to determine what two values would encompass 68%, 95%, or 99.7% of the data.